Hey everybody, it's Ms. Smith. So today we're going to learn about X and Y components of vectors. And we're going to do a little review on basic trig functions, so sine, cosine, and tangent. Now, the last 2 days, so Monday and Tuesday, we studied a little bit more harder concepts for things when you don't have a 90-degree angle, but sometimes we do have a 90-degree angle, so we need to kind of review those basic trig functions. So we'll cover X and Y components, and make sure you take good notes today. You are going to need it for tomorrow and the next 3 or 4 days. We're fixing to get into some really difficult stuff. So X and Y components. Now, this is kind of vector components. This is what we're doing, X and Y vector components. I really should have covered this when we talked about vectors not too long ago, but excuse me. I'd like to cover this a little bit closer to when we start getting into two-dimensional forces, because that's really when you use it. So that way those skills are kind of fresh on your mind, and because we're going to be reviewing sine, cosine, and tangent functions. So hopefully this should be a little bit of review to jog your memory, and then I'll show you how to take it from the math standpoint and then put it into a physics standpoint. So, okay, so let's just real quick, let's review sine, cosine, and tangent. Now, if you've had Miss Key for geometry, I know for a fact that she does not teach SOHCAHTOA. I was not taught SOHCAHTOA. I did not even know about that until I taught like my first year of high school when I taught. So I was never taught this, but the reason why I talked to Miss Key about this one time, I said the reason why Miss Key doesn't like to teach it is because a lot of students get really focused on what SOHCAHTOA means, and instead of just taking the information that it gives you. So it's an acronym to help you remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So let me walk you through SOHCAHTOA. Now, if this confuses you, don't worry about it. I'm just trying to give you a little bit of an acronym to kind of help you remember. Okay, so if it confuses you, just forget about it. It's fine. You're not going to hurt my feelings. Okay. So it is SOHCAHTOA. All right, so let's talk about what each of these means. S stands for sine. Sine of theta is equal to opposite over hypotenuse. Cosine C of theta is equal to adjacent over hypotenuse. And then tangent of theta is equal to opposite over adjacent. Now, just to review just a little bit, I'm hoping that you remember what opposite and adjacent mean, as well as hypotenuse. So I'm going to actually draw a little triangle right down here at the bottom, just to kind of review what's what. Now, these are all for right triangles, okay? So I'm going to write this up here. So a right triangle, remember, is a triangle with 90 degrees. One of the angles is 90 degrees. So let's say that this is my angle here. This is my angle theta. And so this would be the hypotenuse, because that is the longest side. And then opposite, just like we were doing in law of sines, opposite would be opposite of the angle. So I'm going to label that as opposite. And then adjacent is the side that is right next to it. Oh, I erased it. Excuse me. Oops. Adjacent is right next to the angle there. Okay, just a little bit of review. So let's get how do we use this for physics? Okay, so let's say that you were given a vector. Okay, so remember a vector is it has a magnitude and direction. So instead of saying I'm going 55 miles an hour, you would say I'm going 55 miles an hour north. So it's got a number value and a direction. So these are represented through arrows. Now, we kind of did that when we did free body diagrams, and you had to put the arrows around the dot. So we're starting to kind of put concepts together here. So this is with arrows. So let me draw you one example of what I'm talking about. I wonder if it'll let me do an arrow like this. Good enough. Okay, so let's say that this is our arrow, and you are given the information that says 40 meters, 40 degrees from the horizontal. Okay, so this is the kind of problem that you would be seeing. So what this would be is this, here's your origin right here. What this would be is, let's say that you were on a football field and you were getting tackled. And here you are, right here. There you are, that little black dot. And somebody comes in and pushes you this way. And somebody comes in and pushes you this way. Well, excuse me, no. Somebody comes in and pushes you this way, okay? The result, depending on how strong each of these forces are, then it would be this direction here that it would come off. So when this force is combined with this force, it comes off this way. Depending on how strong these are, determines your angle here. Now, so let's talk about what it means by 40 degrees from the horizontal. The horizontal is X. So we know that this is our X, this is our Y. Oh, that was terrible. Okay, there's our coordinate plane. So this is 40 degrees from the horizontal. So here we go, 40 degrees from the horizontal. You are now required to calculate how far this is, because we're dealing with meters, how far north it went, or I don't want to say north, how far that way it went in the Y direction, and then how far in the negative X direction, because this is still negative X over here, this is positive X, this is positive Y, this is negative Y. So your negatives you got to use your negatives in this instance. So I want to know how far in the positive X direction, negative X direction, and then how far in the positive Y direction, okay? That resulted in this red arrow here. That's my vector. Okay, so let's do some calculations. I'm going to erase this a little bit. Let's do some calculations. So we're going to call this X, and we're going to call this Y, because technically of my vector, here is my vector that I was given. Of my vector, I have an X component and I have a Y component. So it makes sense to call this X and to call this Y, because this is the X component, this is the Y component. Okay. So we are going to solve for X. So let's look at this. Let's look at the angle that we've got. So if we want to solve for X, well, I've only got one angle. I mean, technically I could figure that one out, but let's just go with the angle that's given. So I want to do this angle. So this side is adjacent to that angle. So we are going to say that, remember this is theta, back up here, so that's adjacent. So we're looking at cosine, adjacent over hypotenuse. Okay, we know the hypotenuse, it was 40 meters. Okay, so we're going to come in and say, cosine of 40 is equal to adjacent over hypotenuse. So the adjacent to this 40 degrees is X. So I'm just going to put an X there. Oop. Put an X there over hypotenuse, which is 40. Okay, so all we do now is some simple math. We multiply both sides by 40. And in our calculator, 40 cosine, 40 cosine of 40. And let's go to the calculator, 40 cosine of 40, hit enter, 30.64. Well, let's go ahead and let's round to whole numbers. Just today, for all of the work for today, let's just round everything to whole numbers. So X was, crap, I forgot, 31. So X is equal to 31 meters. Okay, now remember that you've got to have direction because these are vectors technically. You've got to have direction. So this is where this value is going to go, that's 30. Now, we said that this was in the negative x direction. So we are going to put in negative 31 meters. There's my direction. Now, let's go ahead and let's do y. So I'm going to erase this. All right, so we're going to look at the angle to see, do we use sine, cosine, or tangent? So here's my angle. This is the side I'm looking for. They are opposite of each other, so that means that I'm going to use sine. So sine, here's how I knew this. Opposite over hypotenuse is sine. Opposite over hypotenuse is sine. So I'm going to take sine of theta, which is theta is 40. That's the angle I was given, is equal to y, which is the opposite side. The opposite side over the hypotenuse, over 40. So now, excuse me, now all you do, multiply both sides by 40 like we did last time. So it becomes 40 sine of 40 is equal to y. Y is equal to 40 sine of 40 gives me 26, round to the nearest whole number. Y is equal to 26 meters. So this is 26 meters. Now we still need to say that we have direction. So I'm going to put a positive sign out there to give my direction because it is the positive y value. Okay, let's try another one. Let's do one that looks like this. Okay, so here's your origin here. All right, I need to know everything in the y direction and everything in the x direction. So this is the information that's given. You have 20 kilometers, 15 degrees from the vertical. All right, so that means that this is 15 degrees. All right, so we're gonna call this X, we're gonna call this Y. Now let's go ahead and establish which one's negative, which one's positive. If the origin is here and this is going down, that means it's negative Y. And this is here and going to the left, that means that that's also negative X. Okay, so that makes sense. So this would actually be in the third quadrant where this would be, so yes, both of them are negative. Okay, so let's figure this out. Let's do X first. So if I look at X, here's X here, here's my angle, they are opposite of each other. So they're opposite of each other, so that means since that's opposite over hypotenuse, oh, this is 20 here. Oh, I'm still a laser pointer. This is 20 here, 20 kilometers. So since they're opposite of each other, it's going to be sine of 15 is equal to X over 20. So it's going to be 20 sine of 15 is equal to X. X is equal to 20 sine of 15 is 5.1, blah, blah, blah. We're going to round to the nearest whole number, so 5. Now, we said, when we put this negative here, that doesn't really mean much. That was just me putting notes down so I don't forget. Okay, so we need to make sure that our end answer has our direction. We said that X was negative in this point because it was to the left of the origin. That is negative 5 kilometers. Okay, so I'm going to erase this and let's do the y component. So I've got the angle here, here's y, they are adjacent. So that means cosine, adjacent over hypotenuse. That means cosine. So cosine of 15 is equal to y over hypotenuse, which is 20. So 20 cosine of 15 is equal to y. Y is equal to 20 cosine of 15. Now remember, if you're not getting the same answers that I am on your calculator, I mean, you really should be working this on your calculator with me. If you're not getting the same answers I am, make sure that your calculator is in degrees, not radians. If you don't know how to do that by now, send me a message and I'll tell you how to do it. Oh crap, I forgot the answer. 19. Now, this y component is below the origin, so this is a negative 19 kilometers. All right, now let's get into some kind of tricky situations here. What if you are given something like this? Say that this is the arrow that you were given. All right, well, here's my origin. Here's my origin. And I have something in the negative y direction because it's going this way. That's negative y from the origin. That's negative y. But I don't have anything here or here, so I have no x direction at all. So this is the information that you're given. 6 miles, 0 degrees from vertical. And you may have a scenario like this, okay? So your x component is 0 miles. Your y component, negative 6 miles. Okay, because remember, we're still gonna have a direction. This is still a vector, so it's gonna be negative 6 because it's below the origin. And that's it. That's all you do for that one. Now, last weird scenario that you may come in contact with, what happens if you were given the x and y and you are told to find the hypotenuse, the resultant vector? Okay, that's pretty simple. All right, I think I may have one more that I'll talk about. Let's say that you're given your x and y at this point. So let's say this is going to be negative 15. We'll say that this is positive 30. Not worried about a unit at this point. And you have to find the resultant vector. Okay, this is a right triangle, y'all. Right triangle. Okay. All you have to do is Pythagorean theorem. That's all you have to do. Now, so let's do Pythagorean theorem real quick. So 30 squared plus 15 squared is, excuse me, that would be negative 15 squared. So 30 squared plus negative 15 squared is 675. Take the square root of that. 26-ish. 26. Okay, so my resultant vector would be this way, and it would be 26. And that would be, technically this arrow would count as your direction. But anyway, that's going to be a positive 26. So the other scenario that you would have to find on this particular one would be, what is the angle of this? So yeah, you found the hypotenuse, but what's this angle here, you know, from the horizontal? So we've got to find that. Okay, now, this is where it starts to get a little crazy. I have not been using, when I put this in the calculator, I haven't really been putting negatives and positives in the calculator, okay? Because of how these have been written. So this one in particular. Technically, so let me do a weird color. So I'm gonna write over this. Let's do this yellow color. Technically, here's your x, here's your y. Okay, technically, this angle here is actually this angle all the way around to your y. So if you put negatives in the calculator, like would be 100% accurate, then you will get this whole angle, because when you put negatives in the calculator, it's referring to the entire coordinate plane that is in the negative x-axis or the negative y-axis. So yeah, you're going to get this whole thing is in reference to the coordinate plane. But what we're going to do, we're not going to do that. Okay, just to make life easier, we're just going to attach our negatives and positives where they know that they are. So when you're finding an angle, don't worry about negatives and positives. Don't worry about it. Okay? I mean, if you wanted to, okay, fine, do it. But I'm just trying to keep you guys from getting confused. So, but we decided this was 26, so we are looking for this angle here. Now, we can use, we talked about yesterday how we try not to use solved values, okay? But we can use this one and this one. All right, so this is going to be adjacent over opposite, or opposite over adjacent. So this is actually tangent. All right, so let's do tangent. So tangent of my angle is equal to opposite, which is 30, over my adjacent, which is 15. Now notice I left the negatives and positives out of there, okay? We're just trying to get this basic angle. We're not trying to get this whole angle all the way around. We're not trying to do that. We're just trying to get the angle inside the triangle. All right, so let's do this thing. All right, at this point, you're looking at it going, what do I do now? Remember, you got to get theta by itself, okay? So you have to divide everything by tangent. Okay, now this looks funky and this is hard to put in your calculator. So you're going to go theta is equal to inverse tangent. Anytime you're looking for an angle, you have to use inverse tangent, 30 over 15. So in the calculator, this is what it's going to look like. Second tangent, 30 divided by 15, close parentheses, 63.43. So we'll round to the nearest whole number. So my angle is 63 degrees. Okay, and there it is, 63 degrees. Okay. When we get into reviewing for the exam here in probably a couple weeks actually, I will go more in this particular section because I'm just showing you this one in terms of basic trig functions, so sine, cosine, and tangent functions. I'm not really giving you a good explanation of how to do this in terms of physics. When we start reviewing, I'll show you, we'll have certain types of problems that you will be required to find an angle. So it's okay right now. If I don't think I'm going to ask you to find an angle in any of these practice problems. I think the practice problems I'm going to give you today are more like this one and this one. So today's not going to be too difficult. So anyway, you know where to find